So as mentioned earlier, we're pretty much done with this program. So why did I want to outsource this file management logic into a separate struct that we pass to this job? Well, because that would now allow us to relatively easy replace the input and output mechanism for this job without having to edit the job code itself. Which of course, for this basic demo app here, is not important. Editing this code is simple and no problem. But if you would be working on a more complex application, potentially across multiple teams, in certain situations you might want to write more generic, more reusable code, where people, for example, can easily change the input-output mechanism. Now, what do I mean by that? Let's say that we don't just have a file manager package in this project here, but we also have a CMD manager for the command line, essentially, so for the terminal. So in there, I'll have my cmd manager.go file with the package cmd manager. And my idea is now that here, I want to build a struct, like the file manager struct, that exposes a readlines method and a write result method, which then, on the other hand, contains totally different code. So in cmd manager, I want to have a struct called cmd manager, maybe written like this, where I actually don't need any input or output path. Instead, this can stay empty because I'm basically only adding this here so that I can attach some functions, some methods to it. To be precise, as mentioned, a readlines method and also this write result method here. So I'll copy this definition or this first line of the readlines method from the file manager and paste that in here. And I'll do the same for the first line of the write result method. Also copy that and also paste that in here. Let's then also close these method bodies. And then, of course, these methods will not be attached to some file manager, but instead to the CMD manager. So they will get a different receiver argument. They will get the same input data though, and they will return the same result data, the same return values. But now in here, I want to read user input from the command line, and here I want to output data to the command line. Now let's start with that, because that's simpler. For that, we can use the FMT package and simply execute println and output the data, like this, for example. We could also convert it to JSON here and print the JSON data. That would absolutely be possible. But here, to keep things simple, I'll just output it like this, and then return nil for the error. And actually here, we actually have no scenario where we could have an error, but I'll still keep this return type, and you'll soon see why. In readlines, I want to ask the user for input. So therefore, I'll again output something and say, please enter your prices, confirm every price with enter. And then we can add an infinite for loop where we keep on asking the user for input, so that we print something to the console and say price colon, and then we use the scan function here to read whatever the user entered. So we'll get a price, which will be of type string, and we have to pass a pointer to price to scan, so that that price will be set by the scan function. We'll therefore then in the end, of course, get our slice of strings, and after scanning the input, I want to set prices equal to a new slice that's generated by calling append, where we append something to the old prices, and the new something is that price that was entered. And therefore, after the for loop, we can return prices. Though at the moment, we of course never reach that line because this here never stops. Therefore, to make sure that we have some exit condition, we can add a if check here and check if price is equal to 0, let's say. in which case we can use the break keyword to get out of this loop. And that should be 0 as a string, of course, since we're reading in text input that will be in a string format, so that will be of type string. Now, of course, you could write more elaborate code here to validate the user input, to wait for a different exit condition. Here, I'll deliberately keep it simple though, and instead simply read the data like this, and then return my prices like that, after we entered 0 as a price. Now here, I'll then also not have any error, but I'll still keep this error return type, and again, you'll see why in just a second. Because now with that, we created another struct which has the same methods as the file manager struct. And of course now we could say that maybe to test some things, we don't want to read and write to the file system, but instead we'd like to use this newly added command manager package here with this struct and its methods in the main.go file for our jobs here. And since we have the same methods, read lines and write result, as file manager, it should be fairly easy to swap the file manager for the command manager. Because inside of the job, we're just calling these methods. Inside of prices.go, in the different methods we have there, we are just calling read lines and also write result. We don't care how these methods work internally. So it should be fairly easy to swap things here and create our command manager here by using the command manager package. And then there we of course need a new function to create a new command manager. And here I simply want to return a new command manager struct. Of course, for that we also have to set the return type. That then allows us to call new here, and as a result we'll get such a command manager struct. But now we can't simply use this as a replacement for file manager. Instead, I'm getting an error that this is not of type file manager. And that's correct. It's a different struct and therefore technically a different type. But of course a struct that has the same methods as the file manager struct, and that therefore could be used in the same way. But now we just need to find a way of convincing Go that these two values are equal and that new tags included price job and this entire price job thing here should accept both structs, both the file manager and the command manager. And that's what we'll do in the next lecture.